Okay, so let's take a look at using trigonometry to be able to work with triangles and find missing sides of triangles. So let's first of all, let's take a look at the idea of tangent. Now, Hipparchus noticed something. He noticed something that as the angle got bigger, then he noticed that there was a different relationship between the sides. So, he noticed that this angle, we call this theta, okay? So angle theta. And they just use that to sort of to tell you what angle I'm looking at. It's a math way of saying I'm looking at angle A. And if I put, if I put a theta over here, then I'm looking at angle B. So it really depends on where I put the theta. So trigonometry for tangent is a relationship between the opposite side and the adjacent side. And so if theta is in this corner here where we've indicated here with this, if that's theta, the opposite side is over here. And the adjacent side is here, side AC. Notice that we used capital letter A, capital letter C, and a line over to say that's the side I'm talking about. Now, the hypotenuse in a right angle triangle is always the longest side. It's the one that's opposite the 90 degrees. Now, probably what should happen is that there should be a 90-degree sign here to tell you that that is 90 degrees and therefore tangent's going to work. So in order for this all to work, we have to figure out what the angle is. So the tangent of theta in this case is BC over AC, opposite over adjacent. Tangent is always opposite over adjacent. And so when I'm doing the work, you'll see me write like this. You'll say the tan of the angle I'm talking about is opposite over adjacent. Sometimes I get a little bit lazy and then I say that it's O over A. So the big trick is to be able to be able to figure out, first of all, what is the opposite side, what is the adjacent side. The hypotenuse never ever changes. So let's use tan to figure out this information. So first of all, we're going to have to probably know one side. So if I told you that that side was 10 centimeters, we want to figure out what is that side. Well, here's what you do. You take a protractor and we need to figure out, whoops, that makes it bigger. That's not what I want to do. I want to move this protractor here. And let's figure out what this angle is. So if I put this protractor here, my angle is, and we start at 0. Remember, in this case, we want to start at 0 and climb our way up. So we're starting at 0, we're climbing our way up, and we go all the way to here, right there. So that's about, it looks like 130, but when we start at 0, it's 50, almost 55, so 54. Let's say that angle theta is equal to 54 degrees. So here's what we do. We'll take angle theta is equal to 54 degrees. Now we have to use this thing called a table of trigonometric ratios. So we want to talk about tangent. Tangent is right here, and tangent is here. And here are the degrees as we go down. We need to find 54 degrees. So we go down here to find 54 degrees. 54 degrees is right here. And tangent is this line. So if we draw a line across here, we see that there's a relationship of 1.3764. All right, so relationship of 17364. Let's see what that looks like over here. So I'm going to make a little bit of room here, and let's figure this out. So here's what we do. We say that the tangent of theta is equal to opposite over adjacent. All right, so I don't know what my opposite is, but I know that tan, I don't have to use theta anymore because I know it's 54 degrees. and I know that it's 1.374. That was the relationship. Okay, so I know that, right? So instead of putting tan of 54, I can say that that is 1.374 is equal to my opposite, which I don't know, and my adjacent, which is 10. All right, so we're going to put a 1 under here to make things a little bit easier. Now notice this, we want to know what our opposite is. The problem is that our opposite is going to be divided by 10. If we didn't divide by 10, it sure would make things a lot easier. So let's undo that. Let's multiply both sides by 10. So let's multiply this side by 10 and multiply this side by 10, and 10 goes into 10 once. So my opposite is equal to my 10 times 1.374. And that one we don't even need a calculator for, because if we know that it's 10 groups of that, we know that it's 3.74 is equal to the opposite. There we go. So we use tan, the relationship that Hipparchus found between the adjacent and the opposite, to find out how long the opposite is, because he knew that every single triangle that had 54 degrees would have a relationship between the opposite and the adjacent of 1.374. And we used that to be able to find the opposite for this unique triangle.